Hello, everyone. We're super excited to talk to you today about agents on Cloud Run. I'm Taylor. I'm a software engineer on Cloud Run, joined today by Ryan, a product manager, and Ed from VMO2. We're going to talk a little bit about agentic apps. Agentic apps are a collection of agents, tools, other dependencies. They allow an agent to move forward on its tasks, complete its goals. They might be fronted by that agent, or maybe they're fronted by a web service. And when you think about building them, you think a lot about how you might also have built a distributed system or a web service. Right? You have to think through your framework. Maybe you're going to roll your own, or you're going to use ADK. Maybe it's a synchronous or an asynchronous agent. Do you want it to do work on its own in the background, or do you want to get a response immediately? You're going to ask questions like, oh, should we build it all in one monolithic agent, or do we want to have many agents that we can eval and test separately, sub-agents? Do we want to make more tools, or is it going to use our APIs directly? Then there's a big question around autonomy. Do we want it to have full access to everything and run all night while we sleep? Or are we looking more towards having it be directly interacting with a human? It's more of a human in the loop. They're maybe going to use the delegated authority of that human. These are all important things you think through when you're building an application. And the best part is, Cloud Run today has a bunch of great features for web services, and they also are great features for agentic applications. So scale to 0. When your agent's not in use, don't run your agent. Right? Very simple deployment. One command, bring your agent to Cloud Run. And any framework or container is supported. Source, Docker-compatible containers, everything works on Cloud Run. And we have, of course, many ways to run things. So there are services. If you want to have your agent scale horizontally with requests, maybe it's your tool also scaling horizontally, just like we do today with web services. If you want to have something run with a trigger or be event-based, we have jobs available. You can run your agent container asynchronously in the background. If you want your agent to be always doing work, pulling from a queue, looking for issues, we have worker pools where you can run your agents at a scale you predetermine, always on. And then we have the newly announced instance, if you want a specific agent running right now, a pet agent, you might call it. And of course, Cloud Run supports the agent platform. So you'll be able to ask for an agent identity with just one flag. You'll be able to tell us that it's an agent or an MCP server, and it will show up in the agent registry to be used by other agents throughout your organization. And we make it easy to use an agent gateway that you have. If you just enable ambient networking, you can tell us to proxy all of the traffic of your agent through the gateway to make sure you have secure communication. This brings great observability, governance, and security to agents on Cloud Run. And now I'm going to introduce Ed, who's going to talk a little bit about how they're deploying agents on Cloud Run at VMO2.
Thanks. Thanks, Taylor, and thanks to the Google team for having VMO2 up here. Next has been awesome so far. I also want to thank Ryan, Lisa, and also Taylor from the Cloud Run team. I'm Ed Wright. I am head of engineering at VMO2, one of the largest telcos in the UK. And today, you're going to hear about our story, about how we use Cloud Run and Gemini to solve customer support issues in the contact center, Lumi. So let me tell you about 2 reasons why we needed to build anything at all. And anyone here that works with contact centers will resonate with this picture. First is tool sprawl. Our agents use 5 to 6 tools and systems per call. That can be CRM, billing, diagnostics, knowledge base, or ticketing. And each tab switch costs time and creates inconsistencies. One agent solves an issue different to another. Our customers feel that variation. Second is cost inefficiency. Slow resolution time hits satisfaction. That fatigue leads to turnover, and turnover is expensive. Second, the training a new agent is not cheap. and can take weeks before they become productive in our contact centers. And that inconsistency there also damages our brand over time. We were paying twice over, once in poor experiences and again in training. We knew we had to fundamentally change and rethink how our agents work. And that rethink is Lumi. It's VMO2's agentic AI platform, and it's built all on Google Cloud, designed specifically for our contact center agents. The important bit isn't so much that we built it, it's what we built. We didn't bolt on generic AI assistants onto existing tools. We built something that understands our products, our processes, and our customers. And the platform underneath gave us the runway to do that in months and not in years. So what does this actually do for our agents? We do real-time call summarization. An agent picks up a transferred call and isn't starting from scratch, and even has access to summarization of customers' previous calls. We do flow guidance. We walk our agents through our resolution paths, which means a newer team member can effectively operate at the level of a senior one. And a unified actions layer, and this is a really big one for us. The agents can do things. They can trigger a remote reboot, raise a ticket, update a package, all without ever leaving Lumi. And if you look to the UI on the right, you can see examples of what our agents have access to. So let's get into the plumbing, how this actually works. I'm not going to talk through every box on this diagram. Instead, things worth your attention. Cloud Run does the heavy lifting on the application side, and we've split it into 3 services. A backend for our business logic, an AI agent service that orchestrates all of the workflows, and a front-end UI service. Breaking them out gave us independent scaling and clear ownership across teams. And with Cloud Run's operational efficiency and simplicity, my engineers aren't tuning autoscalers or babysitting clusters. They're building features. And this is where the pace comes from. Second, Gemini on Vertex handles all of the AI intelligence. Knowledge retrieval, orchestration across tools, and summarization. When a customer rings in and says their TV box isn't working, Gemini passes the intent, pulls the right context into AlloyDB, and decides what agents should do next. And that really is the brain of the operation. We run it in, and so a third, as I've said, is AlloyDB. We run this in Postgres, and this means our engineers have one less layer of operational complexity, especially with the ability to run vector search alongside our relational queries. Data flows in via PubSub, and Apogee fronts the API layer. And that is essentially the platform. And what did this buy us? It was actually 4 outcomes and an architecture we wouldn't have been able to stand up without Google Cloud, especially on this timeline. We've reduced average handle time. Agents are spending less time on each call, simply because they're no longer hunting for information. The information is surfaced to them. We have improved first-time call resolution. So more issues are being sorted on the first call without a customer ever ringing back. And honestly, that's what every customer wants, not to have to call us twice. Faster agent onboarding, new starters come up to speed much more quickly. Because the tool guides us through every resolution path. What used to take weeks of shadowing a senior is now done in a fraction of that time. And lower cognitive load leading to better customer experiences. And this one's really hard to put a specific number on, but it might be the most important one for us. When agents are mentally drained from juggling systems, the calls suffer, and now they're warmer and more present in conversations, and customers feel it directly. So if you're taking nothing away from this session, I would really like you to understand these 3 lessons that we learned. 1, Cloud Run's concurrency model simplifies our AI workloads. We expected to spend significant engineering effort on scaling. We simply didn't have to. The platform handled it for us. And this allowed us to focus on the product. 2, a multimodal approach, optimizes both cost and latency. The Gemini family gives us a range of models to use. We use our smaller, faster models for routing and classification, and reserve the larger ones for genuinely complex reasoning. Your users feel latency improvement, and your bill feels the rest. 3, AlloyDB gives us a reliable grounding layer for agentic responses. Hallucinations would kill a tool like this, and having a fast, consistent data source of truth underneath the LLM is what makes Lumi viable at all. So that's Lumi at VMO2, a genuine example of what the platform makes possible when you're trying to move at pace. And thanks to Google for having me up here. And I'd like to thank Shaban, who is from Google in the UK, for being an excellent partner for us for all of VMO2. That kind of support really does make a difference for us. And thank you all for listening. If you'd like to dig into any of this any further, come and find me at the end of the session. And now you're going to hear from Ryan.
Hey, everyone. So hey, everyone, I'm Ryan, product manager for agentic workloads on Cloud Run. I'm excited and honored to present to you some brand new resource type called Cloud Run instances, which is currently in private preview for select customers. You may be familiar with the term instance in the context of other Cloud Run resources. For example, a Cloud Run service is comprised of multiple instances which scale according to your needs. This new resource type, the Cloud Run instance, is only ever one instance, a single copy of your workload running at any given time, and was purposely built for agents. So first, Cloud Run instances are individually addressable. That means you create, update, and delete each instance independently. You can also stop and restart your instance as needed. Second, these instances are long-lived. Similar to Cloud Run jobs, they provide reliable execution that runs uninterrupted for hours or days. Beyond that time frame, you'll be able to configure your instance to restart automatically in order for it to run for as long as it possibly can. This more durable lifecycle is critical for agents performing complex tasks over longer periods of time. Third, instances are directly addressable, so you reach each instance via its own URL, which makes it ideal for interactions with a specific agent. This is essential for use cases requiring human-in-the-loop interactions or multi-agent systems where they need to communicate with each other. And again, because they are long-lived, they can maintain specific context throughout these interactions. And finally, they are on demand. This resource is fast to create and can be up and running in seconds, as I'll show you very, very soon. So what are the primary use cases from an agent perspective for this new resource? First, long-lived individual AI agents. These are the asynchronous agents, like personal assistant agents, such as OpenClaw. These workloads are typically long-running and executing tasks over an order of hours or days. And they process a diverse set of tasks over an indefinite timeline. Examples might be a stock trading agent that's trading stocks throughout the day and summarizing news events. Or a coding agent that monitors issues and submits pull requests. Second, these long-running AI workloads and orchestrators, which covers platforms like N8N, also a very popular agentic workflow tool. These tools are widely used by technical and non-technical audiences alike to build and manage AI-powered workflows. And they also benefit from this simple, cost-effective, and easy-to-maintain resource where they can run uninterrupted for long periods of time. Third, remote dev environments, or what we call the Vibe coder boxes in the cloud. This allows a developer to vibe their app remotely, complete with agents deployed on those boxes or on the Cloud Run instances to assist them. And finally, this is a sandboxed computer for AI agents. So every instance of every Cloud Run resource, whether it's a service, a worker pool, or a job, is already sandboxed. This means every resource's instances are each isolated from each other, which is important for AI agents that might otherwise interfere with each other's processes or files that share their environment. This resource, the Cloud Run instance, enables you to run an agent in a dedicated sandbox without needing to worry about auto-scaling or lack of dedicated access or control over this particular sandbox. So let's look at how easy it is to create your first Cloud Run instance. This command creates a new, individually manageable instance from a container image. And this instance starts in seconds and is ready to serve your agent or dev environment as long as you might need it. So in this demo, I'm deploying a coding agent from a container image. This agent will watch a GitHub repo for issues that are raised and submit pull requests to address those issues. So here you can see I'm saying this instance should get a URL and public internet access. Opening on port 8080. And now I'm going to set a timeout for 8 hours. Again, this is a long-lived instance, so it can run for that long or longer. And then I'm going to deploy it, which should take just a few seconds. And there we are. Now that it's deployed, I want to grab the URL so that I can actually interact with it. Later, this URL will just appear right as you deploy, but for now I do have to fetch it. And yeah, there's the URL. Needs to load some front-end assets first. And there we are. So it's running. So this, again, was something that I vibe coded myself. And what I'm going to do is I'm going to input my GitHub repo that I want it to watch for issues, and also my GitHub token, and then deploy it. And now it's running and watching for issues and creating fixes on the fly for it. So now it's going to iterate through these issues one by one, and it'll keep running. And meanwhile, I can go do something else and check in on this agent later, because again, it can run for the full 8 hours. Now, at this point, I've let the agent do its thing for a little while, and I want to check on how it's doing. So I'm going to pause this agent and interact with a new Cloud Run tool that I believe has never been shown in a recorded demo before. So I'm excited to show this. This is SSH Access for Cloud Run. We're particularly excited to be able to demonstrate this feature. As we know, many of you have been wanting this for a while. It's with sufficient permissions, I can SSH into the Cloud Run instance with just one command. And once I'm in, I can go look at the code that the agent was writing. So here it's telling me where it wrote the code. I'm going to go to that directory, and indeed, that's where it is. And why not vibe code our vibe coding agent? So I could also just start Gemini CLI within this instance. Again, you can treat this as sort of like a dev environment and do what you want. And another popular agent you could run here would be, of course, OpenClaw. Oh, sorry. So anyway, yeah, you can run any long-lived agent in this environment. That's what it was built for. In this part of the demo, I'm showing that this is all the pull requests that it has raised over several minutes' time. So it's been doing work while I was doing something else. So we saw how SSH worked with this particular resource type, and that's one way that you can interact with this resource. And that's useful for checking the file system, inspecting any running processes. Maybe you want to change files on the fly, or test connectivity. So it's a powerful tool for troubleshooting. The second mode of interaction is called dev mode sync, which is designed to accelerate your inner development loop. It syncs source files in real time from your local workspace to the Cloud Run instance, allowing you or your coding agent to iterate faster. Hopefully, many of you saw this feature in action in a previous session hosted by my colleagues, but I want to show you one more exciting thing about instances. So whoever here was thinking, OK, Ryan, this sounds great, but what will it cost? Well, there you go. So for the same price of a cup of coffee or two, you could run an OpenClaw agent or an end-to-end workflow or your custom vibe coding environment, turn it on, leave it on for the whole month, and not pay that much. Our pricing model will be based on shared CPU allocation. Since your agent may spend a lot of time idle or waiting, you don't need your CPU all the time. Shared CPU comes with a fraction of your instance's CPU allocation as your baseline amount, beyond which you can burst up to your full CPU allocation for short periods of time. So users typically run workloads below their baseline amount for most of the time and only occasionally burst to their full allocation during high usage. Now, some of you may be wondering, is this Cloud Run instance thing the same as this agent sandbox or code execution sandbox that I keep hearing about as this hot new thing in the agent world? Well, let me tell you about another Cloud Run feature called instant sandboxes, which are also currently in private preview with select customers. So isolated sandboxes are useful for executing untrusted code in your agent environment, such as code generated by an LLM, or for running agents like sub-agents themselves. This capability enables your AI agents running on Cloud Run to do math, write code, or execute tools safely and securely. The creation of these sandboxes is also designed to be extremely fast. Again, every instance of every Cloud Run resource is already sandboxed. However, by creating sandboxes within an existing instance, perhaps where your agent is running, we can achieve much faster creation times than if you were spinning up a new per-instance sandbox every time. This is key because speed is critical for these sandboxes. Your agent's responsiveness relies on these fast execution times. So creating your first sandbox is easy. Assuming you've enabled this feature, you can SSH in to any instance of any Cloud Run resource, and then use this sandbox CLI directly to execute your first sandbox. Now, normally, your agent would use an SDK to do this, but the CLI works well for demo purposes. The SDK will make it such that agents from various frameworks can integrate with us without bespoke workarounds. So here we are, SSH into an instance of a Cloud Run service, and we're going to see how this works. So there's a few commands of interest. Let's try them out. So first, sandbox do is one of the most essential commands. You can think of sandbox do in three parts. First, spin up a sandbox. Second, execute a command inside that sandbox. And finally, when the command is finished executing, delete the sandbox. So here we have a simple hello world example and a simple math calculation done in Python. Each of these processes runs in its own dedicated sandbox, completely isolated from each other. We can also just run a sandbox. And this one I'm going to run in detached mode because I don't need to see the logs for this demo. I'm just going to reuse this sandbox for a few tests. So we want to test, is this really a sandbox? So we're going to run two different tests here. One with touch command to see if it can actually modify anything on the host file system that it should not be able to. And then another command to see if I can access any host environment variables that I should also not be able to see. And indeed, looks like we've passed both tests. So this is what you want to ensure for your sandbox to ensure that it's fully isolated. It should not have unrestricted access to files or any other processes, environment variables. Even network access is restricted from this sandbox. Now, let's see how instant this instant sandbox really is. Speed is critical for these sandboxes because your agentic workload will presumably be doing lots of these tasks, and your users will notice if your agent takes a long time to do a simple 1+1 operation. So let's do a test to see how fast this really is. So this test script runs sandbox do with a simple command, pwd, and times it. And it does this 10 times, so we can take an average over those runs. So now I'm going to run that script. So there you have it. An average of, yeah, thank you. So yeah, this was just one time running it, and average latency of under 400 milliseconds. Even the slowest execution was barely more than 400. So now I feel confident that this sandbox tool will not slow down my agents, and my end users will feel like this agent is very responsive. Okay, so let's now dive into how to overall deploy agents and MCP servers to Cloud Run. Here's the architecture of a typical agentic application that you could host entirely on Cloud Run. Let's say you want to build a game where the other player is an AI agent. The game itself, I'll probably deploy to a service so that it can scale if I want to invite more players. And in this case, I'll deploy multiple agents. Maybe also on a Cloud Run service if I want them to auto-scale. Maybe on a Cloud Run instance if I want it to only exist as a single instance and run for longer periods of time. And then I can also use the A2A framework to enable these agents to collaborate on their in-game tasks. And finally, a Cloud Run service is also a good fit for a stateless MCP server. So when I deploy these workloads, it'll be just like any other non-agentic Cloud Run deployment. But I can also add a few flags to the deployment command in order to take full advantage of the Gemini Enterprise Agent platform. Deploying the MCP server first, it'll register with agent registry as an MCP server and also give it an agent identity. The same goes for each of the agents, which will also be registered. This will enable me to include my agentic workloads from Cloud Run when I manage and observe these workloads across my entire Google Cloud project. So here's my vibe-coded blocks game where the goal is to build the highest tower you possibly can using letters that spell next. I play this game collaboratively with agents. I take my turn by placing a block, and then the builder agent goes next, and it calls a physics agent for help in figuring out what's the best letter block to drop and where. And here I'm showing you the A2A agent cards of each agent, where each agent advertises their own specific skills, whether it's building blocks or physics rules. And now the logs. First, the physics agent, which shows the calls being made to it from the builder agent and its own calls to the MCP server. And then on the MCP server's logs, I can see the calls being made for the specific tools that the physics agent needed. Yeah, and there you have it.